Okay, I'm Paul Heitus from the SMT. I'll be moderating this afternoon session. We're very excited to learn about data-driven innovation. So we talked about privacy. I think we talked a lot about the cost of firms collecting information. Hopefully we learned some of the benefits in the afternoon session, which is part of the regulation. Let me very briefly follow the sort of precedent of introducing the speakers, but then I'll get to the speakers as soon as possible. So I meant to introduce Susan Athey and Hal Varian, and I'll introduce both of you immediately. It's a little ridiculous to do so because probably everyone, at least all of the economists in the room will know the two. So Susan Athey is at GSB Stanford. She had appointments at the top universities. If I'd go through the list of honorary doctorates and affiliations like the American Academy of Arts and Sciences, we won't get done with the session. So let me just mention that she won the John Bates Clark Medal, the Junior Nobel Prize in 2007. Maybe I should say something about what's her most important work, but I've learned in the past that that's dangerous because I happen to know certain papers and others know other paper. So, monotone comparative statics, single crossing, I would think, and of course collusion as an IO economist. Other people will talk about identification and data, so, the beauty lies in the eyes of the beholder. Who knows what's the most important part? Hal Varian, and I should say she, for years, was the counseling chief economist at Microsoft, which might add to an afternoon session some inside kind of knowledge. Hal Varian, the counterpart, he's the chief economist at Google. He's a professor at Berkeley and the economics department, the Haas School of Business, and for information management. Here I can add a little bit of knowledge. So with Hal Varian, I know what his most important paper is, and it turned out, or his most important work, and it turned out to be very different than what we thought yesterday when we discussed what it could be. I figured this can't be so hard to work out with the chief economist of Google. You just look at Scholar Google. And I think this might even come as a surprise to Hal what his most important work is, because it's Grundzüge der Mikroökonomie. So it happens to be written in German. But I see a bunch of students and former students in Berlin. You all went through the book, in German or English at least. So he's written the standard textbooks in economics. He's written many important papers. Again, I'll skip the papers and topics, whether it's public good provision or a model of sales or whatever you have in mind. I'll keep for you, and we'll start the afternoon session with Susan Athey. You have 25 minutes.
All right, very good. So I'm delighted to be here today. It's wonderful to see so many people interested in all of these fascinating issues. So the topic of this panel is data-driven innovation, and so I want to talk a little bit about some of the sort of stylized facts of what's happening in the data-driven economy and put an economic lens to help sort of organize our thinking here and also help us think about what we should expect going forward as more and more of the economy looks like tech firms. I should start out by saying, I spoke at a Fortune 100 CEO conference about a year ago, and the interesting thing about it was that pretty much every company was saying, well, now we're a technology company. And so I think that really portends what's going to happen across the economy over the next 20 years is that successively all the different industries are going to turn from what they used to be to being software companies. And so we're going to have all of these issues that we're talking about, instead of being sort of a piece of the economy, will be the economy. So just to kind of get us started with the motivation, we see recently in the last few years, beyond the sort of e-commerce and information products, more and more of the economy getting organized through digital markets. And actually, I'm sorry, I meant to say, in addition to I always like to start out with conflicts and relationships. So for many years, I was consulting for Microsoft, but I'm not speaking on behalf of anyone today. I'm also on the board of directors of Expedia. So as we talk about these antitrust issues, Expedia has also been interested in what's happening in this space. So, we're seeing marketplaces come into more and more industries, from, hotels to taxis to other services. Here's a headline from the Wall Street Journal. It says there's an Uber for everything now. And indeed, in Palo Alto, I can push a button on my phone and someone will come and give me a massage at home in an hour's time. They'll show up with a table. Someone can come and rake my leaves or anything else I want to do. I can get these on-demand services in an app. And just to see that these types of data-driven innovations are really spreading throughout the economy. At the same time, the kind of traditional platforms, if you like, or the big tech giants have an even larger kind of reach across the economy as more and more things get digitized. So as we see more and more of our commerce coming through digital mechanisms, especially our phones, we are seeing more and more importance of those of digital commerce. So I taught a class on advertising this spring at Stanford, and we had CEOs of major advertising agencies and marketers coming in. And so this seemed to be the year that sort of, digital was sort of eclipsing traditional media in terms of their focus, where mobile and it was eclipsing PC, where display was starting to catch up with search, and where really online becomes the central focus for advertising and marketing. And then within that, and within digital marketing, Google has always been the 600-pound gorilla for trying to advertising through Google Search, advertising through Google Display. Facebook is starting to become a bigger and bigger player. It's still, an order of magnitude smaller than Google, but becoming more and more important. And so we're seeing these sort of fairly small number of firms really being the gateway between us and our digital commerce. On the telephone, if you think about looking for a coffee shop or something else that used to be sort of an offline transaction, now we're going to be looking through our apps. And so you can just imagine if the power that comes with that. If Apple decided that it didn't like Starbucks, or that Starbucks didn't pay and didn't show you on its maps a Starbucks and directed you to a different coffee shop, that could have a big impact on commerce. When you think about wallets, so Apple and Google having wallet services that help you manage your credit cards, the whole financial services industry is starting to really worry about the power of these intermediaries. After all, you could have a preferred Apple credit card, and if Apple auctioned off the right to be the preferred credit card, that could put pressure on the fees that the credit card charges. They could auction off being a preferred banking provider, and so on. So all these different parts of the economy are impacted by the intermediaries, these intermediaries that get between the consumer and their services. As well, on the enterprise side, we're seeing everybody moving to the cloud in terms of their information processing, their storage. The machine learning software is getting put out as a service on cloud providers. And again, there's a lot of concentration in that space, with Amazon being very big, also Google and Microsoft playing in the space, and the economies of scale are very large there as well. So this is sort of the backdrop against which we need to be thinking about these issues, that basically a small number of firms is getting between consumers and everything, and getting in between firms and everything. And so we want to understand what's going on there. Partly we want to understand, why is this so concentrated? Is it an accident? Is it monopolization? Is it something that we should expect? And I think it's not going to be too surprising to anybody that I would say the prediction is that we are going to be looking at a handful of firms in all of these industries. And so what we're going to sort of hope for is sort of two or three, but we're not going to get much more than that. And it's going to be very, very delicate getting to two. At the same time, there's a huge difference between 2 and 1. Very, very big difference. And you think of like cloud computing, it's getting sold sort of at cost or below cost in this battle to attract consumers. It's a very big difference if people exit and you just have one. And so that's going to be a real issue for regulators. And if we think about privacy and security as dimensions upon which firms can differentiate, if we don't have market forces there, then there's going to have to be a bigger role for regulation. And that's, of course, on top of the fact that market forces, as we've heard this morning, work very poorly for incentivizing privacy and security to start with. Oops. So let's think of, first of all, just a little bit about what classic economics would tell us about concentration and economies of scale. So you think about classic economies of scale, it's I need to build a factory, and a factory costs a certain amount. And so as long as the market's big enough, more people can enter, and you'll be able to support more factories, basically. But there's essentially a fixed thing that has to be built. And one of the big characteristics of all of these technology products is that there's not a fixed level of quality or a fixed level of investment that's going to allow you to produce a widget that can be competitive. Right? Microsoft can make the most beautiful Windows phone in the world. It can have a better interface than other people's interface. Cortana can work better than Siri. But ultimately, if you don't have the same applications, the quality is lower, and you basically can't pay someone to carry around a Windows phone. And so it doesn't just matter that you can't just buy the ability to have a better product, but actually you need your product may rely on the ecosystem, or in some cases data-driven machine learning, to be good. And there's not just a fixed quality that you have to get to, but rather you need to have not just as many apps, you need to have more apps than your competitors, or as good apps. If you have half the apps, that's just not good enough. So to kind of put this in the context of, again, economic framework, we can think about different sources of scale economies. And by scale economies, I just mean really broadly anything by which bigger is better. So on the supply or cost side of platforms or digital platforms, there's a lot of fixed costs that don't grow as you serve more consumers. So just setting up a platform, creating the content, the research and development to create good content. Just like if you're researching a news story, it costs the same amount to research the news story whether you show it to 100 people or 10 million people. It costs the same amount to pay 5 engineers to build an algorithm, whether that algorithm is going to be used on 100 people or 10 million people. And there's actually a fair bit of R&D that goes into a lot of the algorithms. Of course, Amazon is amazing at making recommendations, and they've been fine-tuning those algorithms for years. Google's search algorithms and Bing's search algorithms are things that have been incrementally improved over many, many years. And there's hundreds of millions or billions of dollars of R&D that go into those. In fact, it's getting more and more expensive. There's all this competition for talent. One of the big news this spring was a new PhD from Carnegie Mellon in machine learning got a 7-figure job offer as a new PhD from a tech firm. So it's very expensive to recruit the best researchers. There's a lot of learning by doing then that goes on here, and that's something that we understand already in economics, but it's a really big force in this area. And so there's a term called endogenous sunk costs, which is used in the economics literature to describe scenarios like this. And basically what the term means is that when you say endogenous, that means that it's determined in equilibrium. It's not pre-specified. So there's not just a cost of building a factory, but you have to decide how much to invest in the factory. So all of these decisions, how many engineers do I hire? How many million-dollar scientists do I hire? How much R&D do I do? That's a choice that's determined in equilibrium. And of course, that's going to be influenced by the competition and other factors. And so the levels of investment are something that the firms are going to be choosing, and if you're going to be competing in a market, you're going to need to make sure that you invest enough that your product is as good or better than your competitors. What this can mean is that, in principle, actually, firms can make enormous profits afterwards, but they might compete them all away. So think about video game consoles. They spend billions of dollars developing the Xbox console, and then they hope they make it back over the next 5 years, and sometimes they do, and sometimes they don't. And about half the time they do and half the time they don't. So it's a huge R&D up front, and they're choosing that level in order to see if they have a better console than their competitors. If they don't, then they're going to lose the generation and the whole thing will lose money. So this is kind of an environment you're in, and we know that the equilibrium in those kinds of markets is going to be a small number of firms, and often 2 or 3 will be an equilibrium number of firms. They're just going to scale. If the market grows, you're not going to get more firms, you're just going to get more investment. On the demand side, we're going to have things like indirect network effect or cross-side network effects, where, say, the more users you have, the more advertisers you have. Those types of network effects, they're not as much same-side network effects, but cross-side network effects. The more users you have, the more applications you have. Those types of things will also lead to big scale economies. And of course, that's why everybody thought, Windows was going to be a monopoly forever. And in some sense, they might have been if it was just a PC, but then a new form factor came along and they lost that form factor. So you tended to only sort of see big changes in market leadership when you saw some sort of other change in the market. So there was an opportunity with, say, going from PC to mobile to have a new operating system, and indeed that did change the market leadership. Similarly, with Google Search, there was an opportunity for change between the PC and mobile, but Google invented Android, or bought Android, and entered the phone market. They also entered the browser market, and that helped them to survive this transition from PC to mobile. They might have lost it if Apple, say if Apple was Microsoft and had their own search engine, then Apple might have dominated mobile search, and you would have sort of competition in search, but that's not what happened. And so, but more broadly, when we think about what's happening on the demand side, the thing really to emphasize is that there's not some sort of minimum number of users you need or minimum level of scale you need to be profitable. Instead, what consumers are going to be choosing is the best product. And so what matters is whether you're better than your competitor. And in those types of environments, there's going to be a lot of interesting dynamic investment, a lot of dynamic behavior, where firms are going to really worry about someone else getting more market share and getting ahead, because it's sort of this race to be the leader. And you're going to be very worried about letting any competitor get a toehold. Oops, I keep hitting the button. So just to kind of give some examples where data can be sort of a business model and a source of competitive advantage, one example I like is Zillow. So Zillow is a company in the US that helps people find houses. And so they got started by just going out in a hard slog and collecting public data. But they put it into a proprietary algorithm that allowed them to predict home prices. And it was the first time consumers could look on the web and see all the homes in their neighborhood and how much they were valued, even the ones that weren't for sale. By making this great consumer product, they attract a lot of users. Once they have lots of users on their website searching for homes, then people who are selling homes really want to make sure that all the best information about their homes is on the website. And so so sellers are going to upload extra pictures. Real estate agents are going to make sure that when their house is for sale, all the information is on Zillow. Then once Zillow has all these users and this special content, it also can attract advertisers, and it can get advertisers to do native advertising. So just like search advertising is special, you don't just put up a random display advertisement on search, you put up a text ad that's sort of part of the content. On Zillow, advertisers are real estate agents trying to get clients, and they make specially tailored advertisements on Zillow, and Zillow makes a lot more money from advertising than just your average newspaper website. If you're big, you can get advertisers to invest in making those kinds of specific investments and really valuing specifically the inventory and the users that you have. And so this is a way that then Zillow gets big, and then it becomes harder for people to compete with it once it has all these users and all these advertisers. There's a similar story in search. Now, search is a really brilliant example of data-driven innovation. In some sense, search, the whole product is an information product. That's what you're trying to get. And there's a few points I want to make about search. I think one of the biggest ones that most people miss is that when you think about Google or you think about Bing, you think about yourself as a user. And you think about yourself as choosing a search engine. And when you think about competition, you just think about, you imagine that the way that search competition works is a bunch of users are deciding whether to search on Google or search on Bing or do other things on the internet. But that's actually really a small part of the way the business works. And so when you work in the business, you actually see what's happening behind the scenes and realize that the business is much more complicated than that. So what happens in search is that, for example, there are defaults on browsers. So why do you think Google needed Chrome? Well, it turns out that the share of Bing searches on Chrome is much, much lower than the share of Bing searches on Internet Explorer or Edge. That is, the browser has a big effect on which search engine you use. There are lots more Bing searches coming off of PCs than off of other devices, more coming off Windows Phone than coming off of Android devices. And of course, Google has to pay billions of dollars to Apple in order for Apple to use Google Search as the search default on Apple. And so if that search default switched, a bunch of users would be using a different search engine on their Apple phone. So the key is that many, many aspects of which search engine you use, not all of it, but parts of it are actually determined by business deals rather than just user choice. And if you did a business deal that shifted a lot of users from one search engine to the other, then the search engine that got the more searches could make itself better and could make its quality better. So in that type of environment, then you have to think, well, what determines who wins the business deals? Well, people pay for the business deals, and what do you pay? You share the advertising revenue. And so the more advertising revenue you make per user, the more you can afford to buy the searches that are up for sale, which is a part of the market. So the market is actually much more complicated than just a user choice model that we all think about. And the market is also very important from an entrepreneur perspective or a business perspective. If you think about, say, European businesses or even well-established American businesses, even like Amazon or Expedia, so on, rely on search engines in order to get a lot of their traffic. And so they're going to be very concerned about how the search engine treats them and what the prices look like for advertisements. And so one way that a search engine can affect things for businesses that depend on search engines for traffic to get discovered is if they reduce the amount of advertising inventory available, if they make more of their own prominent content on the page, it can get more expensive to get consumers. And so one of the things that a lot of the industry has been noticing is that it's been getting more and more expensive to get traffic from search engines over time as the search page itself has integrated more of its own content, say like the hotels and so on. That's of course the subject of the European Commission investigation. So how do I feed data into all of this? Well, we can think of there as being sort of these feedback effects. So the more users you have, the better your algorithms work. That is, for a fixed set of computer code, it's going to perform better with more data. The more users you have, the more advertisers you attract, and the better job you do matching advertisers to users. That's also algorithmic. Then the more advertising dollars you make, the more you can afford to buy traffic from publishers, newspapers, partners like AOL or other types of Yahoo, other types of providers that actually bring in search traffic. And then the more you have of that, the more users you have and the better your search engine. So, and at the middle of all of this is innovation and experimentation. So I want to just take a few minutes and talk about experimentation and how it works. If you live in Silicon Valley, you kind of know this, but if you're far away, you may not really understand exactly how all of this works. So you may not know that every single thing that changes on the Google page, on Facebook, on Bing, on Amazon, every single thing that changes goes through randomized controlled trials. Everything. So you're running 10,000 randomized experiments every year or more to try to make your product better. So what you do is you have a team of engineers, they go out and they invent a better algorithm, something that helps predict a little bit better, and they're going to test it. So you're going to take users that come in, put some of them in a control group, and you have a big control group that you use to compare to lots and lots and lots of different experiments. And then you look at the results of the experiments and you see, was your new idea good or not? If it was good, you immediately implement it. This is actually a new way for innovation to occur. You read these stories like Silicon Valley innovation, it's all about Steve Jobs. Well, that is like, you know, every 5 years, like you have a Steve Jobs style innovation. The real bread and butter of Silicon Valley, of the big tech firms, is incremental innovation, one after the other after another. They figured out how to decentralize the innovation process and enable even the lowest intern to be able to release code to the users. An intern can come in, try something out. If it goes through the randomized controlled trials and looks good, it ships, like the next day. Okay? So this is a really different way to run firms. It's incredibly powerful, and this is going to go throughout the whole economy. Okay? There's a few things to notice about it. One is that you need a lot of users. If you're going to experiment on users, you need a lot of users. And you're going to learn faster the more users you have. So that's going to be a very important part of innovation. A second thing is that these live users are going to be very, very useful. You're seeing the users in context. You're trying to improve performance of your algorithms on your website, in your mobile app, in context. This is a different abstraction than what I think a lot of people think about. They think about data as being like something that's on a hard drive that you might like ship from one place to another. You know, you can sort of buy and sell it. And yes, some of that happens, but the innovation process is about experimenting on live users, and that's what I think is really the source of a lot of ongoing innovation. So this is going to really increase the pace of innovation. These are some older quotes I have on here, but they're just basically saying that, you know, if you fix something, if something breaks, you can fix it and change it within a day. You're going to change your products every day. You're going to release bigger changes every 2 weeks. And that's going to be able to happen in a very decentralized and efficient way. I should say that I have a lot of other work talking about some of the limitations of this, so I don't want to argue that this is perfect. One of the big limitations of this is it actually pushes people to be short-term, because it makes the engineers want to invest in things that can show up in the experiment as looking good within a day, and they don't want to invest in things that look bad the first day but look good in 2 months. So it actually distorts innovation as well. But for small types of changes, it works really well. So just to give an example of the kind of thing that you can learn, this is an experiment that I ran for the European Commission about the effects of re-ranking search results. And so what I did was I took a few million users on Bing, and right before the users got their search results, we flipped the order. So I'm showing here the results of flipping the thing from position 1 and putting it in position 3. So in this experiment, the click-through rate for position 1 was about 25%. But then if you took position 1 and moved it to position 3, you lost that red box. 13.5 percentage points lost, about half your clicks. Now, to do this type of analysis, it really helps to run a randomized experiment, because we know that things that are in the top position aren't there randomly. Things that are in the top position are in the top position because they're better. So if you just looked at what was normally in the third position, what's normally in the third position had a 7% click-through rate. So I did the experiment, and I could see, well, if I took position 1 and moved it to position 3, it would actually have a 12% click-through rate. And so, that light blue box is the difference between correlation and causality. That is, the thing that was in the third position was worse than the thing that was in the first position normally. But if I take position 1 and move it to position 3, I intervene, I'm going to lose about half my clicks. So this is an example. This is not a typical experiment you would run at Bing, because normally you're trying to improve things. This was an experiment intended to learn about something. But because I have the data and I was able to publish it, I can use it to illustrate a point. And that point is that one reason you need lots and lots of data to make these algorithms work is that they always are going to work better if they're more personalized. So in terms of personalization, here I can ask the question, well, yeah, there was this big effect, but I'm sure that it's different for different types of queries. So maybe I can use a machine learning algorithm to figure out for which types of queries is the effect big and small. And this is actually part of my scientific research right now. So I'm going to show you the output of an algorithm that I've been working on that's coming out in Proceedings of National Academy of Science. This is a statistical algorithm. But what happens when you apply the algorithm is you try to break up all the query space into subgroups, and then I look for the treatment effect within each subgroup. And I use the data to figure out which subgroups have big and small treatment effects. So in this example, queries that were classified to be likely to be good matches for celebrities and good matches for images actually had almost no effective manipulation. And that was basically because people actually weren't really clicking on things to start with except for pictures. They weren't really clicking on these links. So there was no manipulation effect there. But for more informational queries that were a good match for Wikipedia, for example, there was a bigger than average treatment effect. And so this is going to show that the effects are going to be very different. I have thousands or even millions of possible ways I can break up the data. So the more data you have, the more finely you can look at this. In my data set, I had millions of observations, but because Microsoft doesn't have a lot of mobile traffic, or they didn't at the time especially, I couldn't actually estimate the separate effect of being on mobile. But of course, you would have liked to do that. You would like to compare mobile to iPad, to Android tablets, and so on. You're probably going to get a different effect for every screen size. And also forget about what country you're from, or what state you're from, or what city you're from. They're all going to be factors, how fast your bandwidth is. These are all factors that would affect, that would interact with the treatment effect. And so that's really kind of hopefully gives you sort of some sense of why you need so much data and how you can keep using more and more data to make algorithms good. So here are just some quotes from an academic article about click prediction at Google. They talk about how a typical industrial model provides predictions on billions of events per day using a correspondingly large feature space. So that is, we're going to have billions of variables. I'm going to run a big regression with billions of variables in it, literally. Why do I need so many billions? Well, if I think about it, I need to predict whether when a user types in athletic shoes, if a Nike ad for running sneakers is a good match for athletic shoes. So I have to think about all the words in the English language that could go into queries and interact them with all the words that could be in the ad. So they usually do it with bigrams, pairs of words, or trigrams, triples of words. So think about the cross product of all the bigrams and trigrams and unigrams in the English language across itself. And that's the potential space of covariates before I even start breaking it up by phones and location and everything else. So so basically the way these models work is they just keep getting more and more granular until I run out of data. And so if we only had a few ways to split, we would still have lots of data per cell, but we have essentially an infinite number of ways to split, and so we just keep splitting and get more and more precise. So of course, in some context, if you have a very easy problem, then you can have enough data to basically explain, to be 98% accurate, and you're done. But in search, the problem is so hard that you're not 98% accurate. You're far from 98% accurate. And so you can keep using data, more and more data, to try to make yourself better. And so in this example, then the author said, we were unable to project down lower than several billion features without observable loss in the accuracy of the algorithm. So just to kind of sum up then, and kind of hopefully I've kind of given you some idea of like how the scale of the kinds of complexity of the algorithms that are being developed. Some of the themes to kind of take away is that there's a big difference between historical data versus live users for experimentation and optimization. If you think about trying to learn the position effects that I showed you from observational data, you would have to do a really complicated analysis. You could write a whole PhD thesis on it and maybe not get the right answer. We ran an experiment, and in 2 weeks, we had a definitive answer. And then I put machine learning on top of it, and I could get a definitive answer for all these different subgroups. So being able to run an experiment allows you to learn definitive things very fast. And you're basically like doing that every day, multiple times a day in these firms. Learning by doing is a really important part of this. You're just getting better and better and better all the time. There's a big difference between data that can be bought versus data in context. In terms of personal data, one thing I mentioned I didn't have as much time to talk about today is that advertisers actually really do want more data and can really use it to make things much more efficient and make advertising much more efficient. So one of the problems advertisers have right now is that most of their ads are wasted. They're showing the same ad. I did some work with ComScore data, and I showed that people were basically seeing the same ad. Like about half the impressions were getting shown way too many times to a small number of people. And a lot of the ads are not even seen by humans. And so better data would really help advertisers do a better job of giving the right ads, more effective ads to the consumers. It would also really help them measure their ads. And that advertising revenue is what fuels a lot of news and other websites on the internet. So that's one place where like data that could be shared about personal identity is actually a very, very useful thing. So finally, I think it's just very likely that many data-driven markets will be concentrated. Many platform markets are going to be concentrated. We're not going to see very many opportunities for changes in leadership. They're mostly going to happen when you see a new form factor come along or some new technical change. And so, really how much competition and how effective the competition is depends on the fundamentals. But nobody's going to want to give up their lead. So whoever's ahead now is going to have a lot of power over consumers and over the ecosystem, and they may want to use it to maintain their lead. So that's something we're going to have to watch out for. Also, in an environment that's highly concentrated, there will always be a regulatory role. It's just going to be hard to avoid. But so, on the other hand, there are things out there where you see multiple firms or you see low margins, like, prices are very competitive on eBay. Amazon's consumer prices are very low. So it's not that we're always going to see bad outcomes for consumers. And so it really depends on the fundamentals of the market, where having 2 firms or 3 firms is going to provide sufficient competition, and where we're not going to really get effective competition. But there's not going to be one answer. It's really going to depend on the fundamentals of the market. Okay, so thanks.
Thank you. That's much better. I don't have to turn my neck to see what I'm doing. So I want to tell you 10 things that you may not know about search. And these are little factoids. Maybe we'll discuss them a bit afterwards. But I think it's important to understand this entire ecosystem the way Susan was describing a minute ago. And here's the first remark, which may come as a surprise. Namely, may come as a surprise if I can get it to move. There we go. Search engines, I think, are the best thing that ever happened for privacy. All right? And why is that? Because it gives you an environment when you can ask a very sensitive question and get a very private answer. So how do I know if I'm pregnant? Or what are the symptoms of herpes? Or how do I know if I'm gay? How to get rid of head lice? These are all questions that people would be very reluctant to ask to their parents or their minister or their lawyer or their friends. But they feel pretty comfortable asking a search engine because, after all, a search engine is much more private in most ways than asking these questions to your friends. And I suggest an experiment that you might try. One is you could go to Google or to Bing and type in a question, how do you get rid of head lice? There's a picture of a head louse in case you haven't seen one. And you'll get an answer back, and it should be a good, informative answer. And wait a week or so, and I think nothing bad will happen. And then the second treatment is to go ask all of your friends, how do I get rid of head lice? And then see who sits next to you at lunch. So having the capability of asking a private question to a machine is very, very valuable to people. And it's something that really we should do everything we can to preserve and make sure that that's available. I suggest down there at the bottom, there's an article by Ben Wittes of Brookings who looks into this question, gives some other examples, and then Seth Stevens-Davidovitz has written a number of columns for the New York Times about what you can learn from looking at search engine data, and you can learn a lot more about what people think and what they think is important and how they view the world from looking at the search engine data than you can by looking at surveys for exactly the reason I just described. People will be much more candid when they're asking questions to a search engine than when they're answering a survey response. Ads. We heard a bit about ads a few minutes ago, so let's talk about the 3 kinds of ads that are important. One is search ads. And when you look at search ads, the query, that is the question that you ask for which you're getting responses from organic search results and from ads, that's a very, very strong signal about what you're interested in. And there's very little that personalization can do on top of that signal from the query. Now there's a few things. There's re-ranking and retargeting and a couple other things that can be done there, but generally, with search ads, the query is such a strong signal that personalization really has little impact on the outcome. The second kind of ads are contextual ads. So if you go to a site about fishing, you may see ads for fishing rods. Not too surprising. Contextual ads are a very old story, and in fact, the content in those cases is an extremely strong signal. And again, the personalization on top of that content really provides a very small boost. In fact, when you look at traditional industries, this is also true in traditional industries. Look at newspapers. Newspapers never made money from news. They used contextual ads on travel and finance and automotive, entertainment, house and gardens, all these commercial topics, and they showed ads that were relevant to that content that was available in the newspapers. Now, along comes the internet and unbundles things. You've got news, you've got sites about automobiles, you've got sites about entertainment, you've got sites about finance, house and garden, all these other things. And so what's happened is that revenue model for newspapers has been disrupted. Because if you think about news, what is news? News are things like earthquakes in Haiti, or a boat sinks in the Mediterranean, or all these crises, typically unpleasant pieces of news. And believe me, there's no relevant ads that you can show next to that kind of content, because the context doesn't work, the query doesn't work. So what do you do for that kind of content? Well, they use display ads, and those display ads can be based on past behavior of the viewer. So you can look at things about what websites they visited. If they visited a lot of websites about fishing, then you can show them ads for fishing rods, even if the story, even if the context has nothing to do whatsoever with fishing. And if they visited a site about railroad tickets, you can show them sites for railroad tickets, even though that may have nothing to do with the particular context that's being unveiled. So when you think about the role of personalization in advertising, it doesn't really do that much on the search ad side, because the query is a strong signal. Doesn't do all that much on the context side, because the context is such a strong signal. But where personalization really works and really is important is when you're looking at situations where there is no query and there is no context, and so you have to base the ad on past history. And this is something where people naturally raise issues, raise questions, ask whether it's a good idea or a bad idea. There's a lot of debate surrounding this, but that's really the focus of the debate, is what do you do when you have nothing else to base your ad targeting it on? Now, the ads that are shown there, display ads, when they're personalized or when they're based on past history, they tend to be worth about 3 times as much as the ads that are not based on past history, and they provide a big fraction of the revenue, 80–90% of the revenue, for traditional web publishing, news, sports, entertainment, that kind of stuff where contextual targeting is hard. And there's a very nice paper I want to recommend by Justin Rao and some of his colleagues on do not track and the economics of third-party advertising that spells out a lot of the assertions I've made in this slide. You can look at the calculations in Justin's paper. Information about your interests. So where do these interests come from? Well, it's all under your control. And what happens is you can go to Ad Preferences in Google and you can say, here are my interests. Now, Google's trying to infer your interests. These are my interests, it says. Banking, okay. Economic news, not too surprising. Mobile phones, search engine optimization. For some reason, it thought I was interested in soccer. I'm not quite sure why. But maybe because I was coming to Germany, I figured you should be interested in soccer. So we'll show you some ads on that. You can add new interests if you want to add additional interests. You can get rid of interests if you think they're not accurate. Or you can just opt out entirely and say, I don't want to see interest-based advertising. I just want to see some random set of ads. So you're going to see the same number of ads, it's just whether they're relevant to your past behavior the way these are, or whether they're not. And it's up to you to make that choice. That's your decision. And here's another way that your data is under your control. Google has a service called Google Takeouts. So you can take all the information that you've uploaded to Google, like maybe your Gmail, or maybe your photos, or maybe your files that are on drives, or your Hangouts, or your maps, My Maps, if you've customized the maps, your profile, Google Voice, all that stuff. And you can download all that data, put it on your own machine if you want. So you have control over the data that you upload, by going to Google Takeouts and then downloading that data. And if you want to offer that data to somebody else, just fine. That's all available to you because we believe that you should be in control of your data. Now, Susan talked a lot about big data, and I absolutely agree. Big data is important, but small data is important too, which people tend to forget. Google uses thousands of people around the world, contractors, to do human evaluation of web pages. All right, so you have a search, and it says, here's one page of results, here's another page of results, which is more relevant, or which has more fresh information, or which has more useful information to you. And so we have this process of experimentation that you heard about, and part of that experimentation is having real human labeled interests, labeled evaluations, labeled assessments of websites and search results, and you do that by using real live human beings. It's not an entirely automated process. So the ratings from evaluators don't determine directly how things are ranked, but they do serve as an input into evaluations of the algorithms that we use in doing this ranking. So it's important to remember that humans are definitely in the loop because after all, the humans are the people that are using these search results. And what we've done is each year we published our human rating guidelines, which is a 146-page document last year, and it describes what is important about web pages in determining your ranking on Google. So as you might guess, this is a very popular document to read for website optimizers and people trying to improve their ranking in Google because it lays out the factors that are important in terms of the assessment of the relevancy of the search results. So if you want to know what's important in terms of ranking, go read this document. It will give you a very good picture of what Google is using to make those evaluations. And switching costs. Switching costs are extremely low in this industry. It's important to understand that it's not whether people do switch that's important, it's whether they can switch that's important. So think about Coke and Pepsi. Some people love Coke and some people love Pepsi, and they're never going to switch. They have their favorite drink. But would we say there are switching costs in that industry? I would say no, because it's just as easy to pick up a six-pack of Pepsi as it is to pick up a six-pack of Coke. You may like Pepsi better than Coke or vice versa, but it doesn't mean that there's any particular cost to switching. If you want to use one product rather than the other, it's perfectly available. And multi-homing on these products that I just described, on the software products, is very common. For example, I use 1, 2, 3, 4 operating systems in a given day. I'm using Windows, Mac, Linux, and Android all the time. Now that may be a little extreme, but it's perfectly common for people to use, let's say, Office tools from one provider, email from another provider, and other components, image, photo storage from yet a third provider. And what's great about this is you've seen that the systems, by and large, tend to be highly interoperable. And this is attractive because even though the market leader in any given one of these areas may prefer to make it hard for people to switch, the people who want to acquire the new users who are competing on the edges with that leader want to make it very easy for people to switch. So you've got these both forces at work at once, and popular applications are available across several different platforms. Tim Bresnahan at Stanford has done a nice study looking at the most popular mobile applications and found that they're available on both Android and iPhones. And the user interfaces are converging, so you're getting a much more standardized user interface, making it much easier to switch. You know, back when automobiles were first invented, there wasn't much standardization in how you guided them. There were people that used pedals. There were people that used levers. There were people that had reins to drive their cars. And all of these were possible interfaces. We converged on a pretty much standard interface for interacting with your automobile. And I expect we're converging on a similar kind of interface for operating with these different digital services. And your search options are under your control. Now this picture is a little bit funny. What it is a Chrome browser, and I went to the search box and I typed YE and hit a tab, and I'm taken immediately to Yelp to do my search. If I typed BI, I'd go to Bing. If I typed YA, I'd go to Yahoo. So what happens is there's a standard called the Open Search Standard, and it's been adopted by both Bing and by Chrome. I don't know about Safari. I haven't actually looked at that one. But it allows you to, from a given platform, from a fixed platform, to search on any other platform with a very minimum of switching costs. So it's something that allows you to search on whatever you want, even if you have a specific browser that you prefer using for general searches. I want to say a word or two about this issue of repeated and rare queries, and I'm using this report from Evaluation and Analysis of Personalized Search Strategies from Microsoft Research. They looked at about 12 days of searches, and they found that 80% of distinct queries were seen only once in that given 12 days. So there's a lot of unique queries, distinct queries that are not seen in a repeated fashion. But on the other hand, there's a lot of repeated queries as well. 47% of the users issued one of the top 3% of popular queries during the course of that 12 days. So these would be things like weather or hamburgers near me or something like that. 46% of the queries are repeated by somebody, and of those repeated queries, 72% are repeated by the same user. So if you think about your own search habits, I would venture to say that in a given week, you're probably repeating certain queries several times. Maybe it's your favorite football team, maybe it's maps of a particular neighborhood and so on. But what that means is search engines have to optimize for both these repeated queries and for the long-tailed and rare queries, because it's a kind of a strange distribution. Now, the repeated queries are easy because you do things like what we call knowledge panels, or you do things with maps or lists or weather that services that are provided, where you really try to optimize those queries, and indeed you'll see that virtually every search engine does a good job on those kind of repeated queries. But the rare queries are the tricky ones. Those are the ones where it's hard to do. These 80% of distinct queries were seen only once in a 12-day period. What do you do for those? Here's what they look like. People hear about long-tailed queries, rare queries, all this stuff. These are some queries that appeared once in a given day. And my favorite one is about 5 lines down. It says, cheap but good auto insurance in Los Angeles, CA. Okay. So only one person issued that query in a given day, and what you have to do is you say, well, what does it mean? What does it mean? The computer, you can't just look it up in a table and find all the different people that issued that query. What you have to do is you have to parse that query and reduce it to its essence. So you have to recognize that CA means California, not Canada, and you have to recognize that Los Angeles means Los Angeles because it's misspelled, and you have to realize that cheap but good really doesn't mean anything. So what you want is you want auto insurance in Los Angeles, California. And same thing with boiler rental in Richmond, Virginia, Marietta, carpet cleaners, New York wedding band, on and on and on. Most of these queries are long-tailed because they're a common query that's tied to a geographic location. And if you ever want a murder lawyer in Los Angeles, well, we'll see. You could go to Google and see what kind of results you get. Or a drug rehab program in Phoenix, Arizona. These are the kinds of queries I was talking about before that you may be reluctant to ask to a human, but you're willing and quite willing to ask it to Google. So the long-tailed queries are not something you can look up a table or just kind of use historical data. What you have to do is you have to really understand those queries in a sense, and the challenge is getting a computer to understand what those queries are and to recognize the user intent. So they aren't unusual. There's something indeed that's quite common, but they require an algorithmic approach to really make sense. And here's a picture of data of the distinct queries that have never been seen before. So before I was looking at data that you hadn't seen in 12 days, or it was unique over a 12-day period, and then I showed you stuff that was unique on a given day. These are queries that have never been seen before. And in November of 2008, 16% of the queries were never seen before. 6 years later, in November 2014, 15% of the queries had never been seen before. So this curve pretty much asymptoted back in 2006, and in fact, you're gaining very little in terms of repeated queries after that time. In November 2008, 30% of the queries in a given day had never been seen before, and that's barely budged in the last 7 or 8 years. So in fact, those distinct queries, the long-tail queries, rare queries, those are critically important, and you're not going to solve them with more data. You can only solve that problem by having better algorithms. All right, so online search is great for privacy. That was the argument I gave earlier. People will talk to the computer, ask things of the computer, they won't ask to other people. Online ads is very important to try to understand this industry, to look at the different flavors, the search ads, the contextual ads, and the display ads. And small data is really important. Small data is a big deal because you have to get the humans into the loop. It can't just be done as an automated algorithm. The online competition, in my view, is about the most intensively competitive industry out there, very intensely competitive, and it has this unusual feature that you're competing not only in the products, but also in the business model. And most of your online data, your data is under your control. You can go to ad preferences, you can go to Google Hangouts, your interests are under control, your search options are under control. Switching costs are very, very low, in part because all of these companies are competing against each other, and all the competitors, except for the leading competitor, wants to make it easy to switch. That's the reason why switching costs are low. That's the reason why the prices are so low. That's the reason why the innovation is so intense. Long-tail queries are not unusual. They're the common example, and in fact, you see them all the time. So those are my points. Thank you.
Okay, thank you very much. It was very interesting. So before I open to the floor, let me use my power of having the microphone. So I sort of noticed kind of a non-common theme. I noticed many common themes, but the non-common theme was, how worried should we be about who has how much data? So you seem to suggest, Susan, that it's really crucial to have the data and to have control of the live data to do the experimentation. Hal, you seem to suggest that you know, that we have many firms, they compete fiercely. You might be the market leader in one of these many sections, but we have cross-market contact. Interestingly, that normally we're worried when there's multi-market contact. But in this industry, somehow the multi-market contact sort of solves a little bit the information problem. And so maybe I'll give it to you first, and sort of I want to see kind of where would we think that there are really problems with information, and where do we think they're known? You go first.
Sure. So I think these are pretty complex design. Great. So these are pretty complex issues, and so in some sense, absolutely, like Microsoft's up at night worried about Amazon, Google's up at night worried about Amazon. Amazon's up at night worrying about Google, and those fears induce firms to be fairly, to try to make their consumers happy. But it's in these complex markets, fear can sometimes lead you to do good things and sometimes lead you to do bad things. And one of the reasons it's a bit complicated is it's not like we're just selling like apples and oranges and so on, but some of these products are actually distribution vehicles for other products. And that's what makes it a little bit subtle. So when I say distribution vehicles, they're the way that you get to your consumer. So if you're selling Office on Macs, you have to get through the Mac. If you're selling Office on iPad, you have to get through the iPad. If you have a travel search engine, you have to get your consumers through Google search. If you're a search engine, you get your consumers through a browser, which is in turn determined by an operating system on the mobile. And so the fact that these firms can direct traffic to, from consumers among other products gives a slightly different lens on this kind of multi-firm competition. So I think there's two kind of relevant facts to think about. First of all, let's go back to Windows. Windows was very afraid of the internet in the 1990s, right? So like you can imagine there's like two things that you could do. They're worried that people will live their lives on the internet and they won't care about their operating system anymore. Well, that happened. A little slower than Bill Gates thought it would, but it happened, okay? So it was a valid fear. And they did indeed face competition from browsers in the internet ecosystem. That was also true. But what do you do when you're scared? You could make a much, much better browser, make your browser so much better that everyone's going to choose your browser. But that might take a few years, and bad things could happen in the meantime. Or you could use your distribution vehicle, which is the operating system, and make sure that everybody has your operating system, has your browser, and that would be much faster and make sure that you got the outcome you were looking for. And so I guess, fear doesn't always lead to good outcomes, especially if you have control, if you currently have control over the consumers. And then presumably that led to a slowdown in innovation on the browser for many years before, finally the quality deteriorated enough that new entrants were able to get market share. So I guess this multi-market contact thing is a little bit double-edged sword when the nature of the products are such that you control access. And then that also leads to, in some sense, one reason, why does, say, Google need to be in the operating system business? Why do they need to be in the browser business? Well, they fear that if Microsoft is the only one in the operating system and browser business, that they'll send people to Bing. That if iOS is the only one in the phone business, they'll send people to Bing. So that's the fear. And so that means that actually they needed to enter these other businesses just to protect their access to their consumers, which could be good or could be bad. But in some sense, some of them, there's cases where there might be almost too much entry. Like, why does Amazon need their own operating system? Well, they're worried about Google making it hard for them to get to their consumers. And just maybe as a final kind of comment on this, if you think about on your iPhone, or I think on Android, I have an iPhone, but if I want to buy a Kindle book in my Kindle app, well, I can't do that, can I? I have to go to the Amazon website and order the book and have it delivered to my device. That's a pretty lousy user experience. Why does that happen? Well, because the operating systems would charge Amazon for the purchase of the book in the application, presumably. So these firms, although they're competing heavily for users, they're not competing so heavily that they actually let you do what you want to do, right? If they were really that concerned about your users, they would let me buy my book in like my freaking Kindle app, like I want to. They know I want to do that. They know this is a terrible user experience, but they don't end up there. And so, understanding that firms can and will hurt their users' access to competitor applications when they decide it's important means that this multi-market competition doesn't always get to the best outcome for consumers. So it's complicated.
I'm sure, Hal, you want to...
Yes, I want to respond to that. Well, first of all, I think the basic premise is right, but it shouldn't be, fear can lead to good consequences or bad consequences, of course. But what does lack of fear lead to? Well, that's a stagnant oligopoly. So if you don't have any fear going on, you don't have any competition. If you don't have any competition, you don't have low prices, you don't have innovation. So it's not a perfect world, absolutely, but it's better than the feasible alternatives. If you look at the example with the books, yes, we would all of us consumers would like things to be even more interoperable than they are. But for a given title, odds are you can get it on iBooks, you can get it on Android, you can get it on Google Books, and you can get it on Amazon as well. So you're getting competition not only on the consumer level, but also on the content level itself. I did want to make one remark about Amazon. Absolutely, They want their own operating system, but the operating system they have is, of course, built on the open source version of Android. And they've taken that open source version and customized it for their own applications, and more power to them. That's why we want Amazon, that's why we want Android out there, because we want it to be a lot of competing devices. Just the way we generally like competition. When I say we, I mean we all like competition in some components, some dimensions of that competition space. Finally, I'm going to add one last word, and that's the buzzword from Silicon Valley, co-opetition. Because in many cases, these same companies that are competing in certain dimensions are cooperating in others. Amazon is a big competitor for Google, of course, but it's also one of our biggest advertisers. So we're both competing with them and cooperating with them, and somehow that ecosystem seems to work.
So before opening the question to the floor, sort of one more kind of obvious question, I guess, which is, if information is so valuable, is it an essential facility? So if information is that valuable, shouldn't I, with a small time lag, the next day, make it available to rivals? That still wouldn't sort of solve the problem that you mentioned, Susan, about being in control of the experiment, but at least I would, in some way, lay open the results of the experiment with some time lag, depending on whether I'm...
Well, let me start with the first lecture in information science. They draw a little pyramid on the board and say, we've got data down below, and the goal is to turn that data into information, and then we want to take that information, turn the information into knowledge, and then turn that knowledge into action. Okay? So when you're entering one of these new markets, you decide that you're going to compete. Suppose that Apple decides to compete with Microsoft in game platforms. Could happen, it's possible. Amazon could do that, Google could do that, any of those examples. What would they do? Well, they'd have to acquire the information, they'd have to acquire the knowledge, and if they got those, they'd pretty much get the data to follow along. What happens is when Google decided to enter the area of voice recognition, they had no data and no expertise. So the first thing they did is they went out and hired the expertise. They got the best people in the world in doing voice recognition. And then to get the data, what they did is they put an application together called Goog 411, which was basically a voice-driven telephone directory. So you could dial Goog 411 and say, I want the number of Joe's Pizza on Palo Alto, in Palo Alto, California. And it would say, do you mean Jim's Pizza? No. Do you mean Fred's Pizza? No. Oh, do you mean Joe's Pizza? Yes. Okay, so that was the training data, which allowed the voice recognition to learn how to recognize voices. It was all done in the cloud, so the data was immediately aggregated and improved on a day-by-day continuous basis, and that was able to jumpstart the voice recognition program at Google. And since then, of course, yes indeed, it's acquired more data, and it's gotten better, and every day it's getting better and better. Now, Amazon with Alexa, they had no expertise in voice recognition at all. But they've come out with a fantastic device that has excellent voice recognition that they managed to build, presumably by acquiring the expertise, by acquiring the people who knew the algorithms. And now that they've got this system in place, it gets better and better pretty much on its own.
Susan, do you?
Yeah, yes, I mean, consistent with what I was saying earlier, I think it's really an oversimplification to think about the data itself as being the main problem or the main fix. So in other words, if you took if Amazon had to share all of its data with someone else tomorrow, that wouldn't make it possible for someone else to enter the core Amazon business of retailing. There's so many components of it, and there's so much about really what they do with the data. But one place I might differ a little bit, actually, it's interesting that Hal was talking so much about these unique queries, because of course the algorithms, you need good algorithms, but how do you get good algorithms? Well, the way you get good algorithms is with a lot of data and seeing how they perform. So these algorithms are, it's not like you're sitting there like writing down a formula that says, how you relate these two English words to this other word. I mean, they're mostly trained off of data, and the way you can kind of parse these rare queries is figuring out looking at all the text in them, all the bigrams, all the trigrams, all the unigrams, and seeing how they match to what's on these web pages. And so, in some sense, the historical data about what people clicked on when they did similar searches in the past, or searches that contain similar words, would be good training data, and absolutely having that would improve algorithms. But it needs to be, it needs to be fresh. I mean, what people want when they say Michael Jackson yesterday and today is different. So you need it not just, oh gosh, somebody once sends you a hard drive full of data and then you're going to catch up. That's not the way it works. You have to continually be improving the algorithms, and also, but even with the same algorithm, they're going to perform, when I define algorithm, like the same kind of rules, the same kind of computer code, if you like, it's going to perform differently on different volumes of data.
Okay, so let's open the floor for questions. I'm sure there are a bunch of questions. I see one over there.
Okay, so this question is for Hal. So you gave a very optimistic overview. So one of your points was the control of data, and actually you mean that I could download it. So I did that once on Google, and I got 10 gigabytes of data. And then I noticed that there was a lot of data that I wanted to delete that, and it didn't work. Yeah? And this brings me back also a little bit to the theme of this conference, privacy. If I put something in the internet and it's not private anymore, can I get my privacy back? What is the discussion about the right to forget? And I would like to hear your opinion about that.
So you're talking about the Google takeouts of downloading the data from Google? Facebook, other places, yeah.
Data in, can I delete my data?
Yeah.
Right to forget.
So what happens, it'll vary from application to application. In most applications, you can delete your data. You can delete all of your voice activation data. You can delete your search history. You can delete many other components which will vanish from Google. However, I will say that it takes a little time to delete data. It doesn't happen immediately. In fact, when we first came out with Gmail, this is a long time ago, whatever it was, 10 years ago, there was no good way to verify that you had actually deleted data, because it was replicated and mirrored in order to make it accessible on an instant basis around the world. Well, now when you delete a Gmail message, you can be assured that it's gone, but it takes a few hours for it to actually disappear in most cases, because these are big, complex systems. So the system isn't perfect, take out, but it does allow you to take down, to retrieve a large number of the data, a large amount of the data that you've uploaded to Google, and we're continually working to make it more and more powerful so that people can delete things when they want to do it.
So I think, there's actually some really big sort of public goods or collective action problems generally around user data that's out there. Now I'm thinking about the advertising ecosystem in some sense. You go to a website and somebody sells a cookie that says that you've been to that website, and you would have no way to know who has that information, and there would be no way to kind of get it back, because there's no way to even really know which one is yours. It's a very complicated system. I used to think that it would just basically be technically impossible or impractical to have a way to kind of get your privacy back. Recently, there's been these interesting developments in distributed ledger technology. This is the technology behind Bitcoin and other firms. And so I think it actually, we can imagine, I know not to say that it's there yet, but we can imagine technology that could actually allow access to your data to be recorded in some kind of distributed way, and where you might have a key to your own data and be able to go back and revoke access to it. And if someone wanted to use it, they would have to query the database. I mean, in some sense, the idea is, if there was some big central database that had everybody's name and you had a password to access that, and all the cookies were associated with you in that big database, right? Then you could already do this. But the problem is, who's going to run this database? How is it going to have all this information? And it would be a security nightmare, right? Because it could be attacked. And So you want to have somehow the concept of some central database where you everybody can control their information and turn it on or off at any time. But I don't think that was really practical before these kind of ideas of distributed databases. So I think it's possible sometime in the future we could have a real kind of forgettability, at least in the business advertising ecosystem. Who would ever actually, even if we had the technology, make it happen? How would you get everybody to cooperate? Lots of vested interests wouldn't want it to happen. So God knows if it ever will happen. But I think it's an interesting concept to think about, that we now maybe at least technically could think about pulling something like that off, even if we're never actually going to get there. And I would also say that, again, we could make advertising much, much more efficient, much more productive, much more useful if advertisers could really have better identity understanding and could really understand how many times a consumer had seen their ad and what else they had done. It would be better for everyone if we could do that. And the problem with that is just control. So if we could solve the control problem, the security problems, and the privacy problems with that, we could actually, newspapers could make a lot more money. We would have much more investigative journalism, and other good things would happen.
If the revenue Google makes comes from advertising, or large parts of it, and the services you sell to consumers are given free of charge, why not, or is anybody considering a model where you offer the same kind of bifurcation of a product like in TV markets? You can either watch free TV and then you have to deal with all the commercials, or you can subscribe to a channel and then you don't get commercials and you pay for the content that you get, for the service that you get. So you could imagine that mail services, search engines come in two forms. One is free of charge and you go with the advertising and any other revenue that is generated from your user history. And there's another product, maybe by the same supplier, where you can sort of delete all that and take the pure product, but then you have to pay something in return for you to use it. Is that a concept somebody thinks about? And if so, what is your personal opinion looking at the future? Will something like that develop, in your opinion?
So I want to emphasize, this is not an ad, but we do have exactly that product in the US. It's called YouTube Red. And what it is, it's a paid subscription to YouTube where you can access the content without any commercial interruptions. We do not yet have that product in Germany, or it has to roll out. The big problem is you have to make deals with all the content providers and the collection agencies in order to offer a product of that sort, okay? So they have to agree that, yes, this is an appropriate royalty rate and so on. But that's negotiation, not technology. The technology is there, it's used today. I think you're absolutely right that it would be nice to give people a choice between ad-supported and paid content. That's certainly what's happened in TV. TV has moved from predominantly ad-supported content in the US. Now a major part of TV is, in fact, subscription services, pay-per-view, and so on. So I think we'll see the industry move in that direction, personally.
Yeah, I mean, freemium models, I think, are popular in a lot of places. I think, actually, that question makes me want to pick up on one of the things that I thought good points that Hal made, was that the business model competition has generally been, very productive for consumers, and that, we've seen lots of things become free. And again, going back to, Netscape versus Internet Explorer, I actually paid $100 for Netscape Gold in 1995 to make my MIT website, okay? So it's any product, basically, that can be used to distribute other products is something that can be subsidized. And so, in some sense, like, a browser is used to distribute search engines. And so as a result, anybody who makes a browser just wants to have as many people as possible use their browser, because then they can sell access to their users, essentially, by selling off the right to be the default search engine. So the fact that some products are used to distribute other products puts downward pressure on them. Android distributes search, and so they want to push out Android to as many people as possible, and that, you know, instead of charging for the operating system and so on. So this can be very good for consumers. On the other hand, we have to think carefully about exactly what's going to happen in a particular case, whether that revenue is going to go in. So just for example, PC manufacturers, if they were getting subsidized to have a default browser, getting subsidized to have a default search engine, they could then reduce the price of the PC to the users. Or if a mobile phone was able to auction off to 2 search providers the right to be their search provider, then that money is like a negative marginal cost on every phone that goes out, and so that can lower the price of phones. So you have to sort of, can be sort of a trade-off. On the one hand, like a business model that links the things together can lead one company to be aggressive about distributing its device, but on the other hand, if the things are bundled together, it's not clear how much of that surplus goes back to the consumer and how much is kept by the intermediary. So these are things that you know, require pretty careful study. But overall, these advertising supporting models have made enormous amounts of free stuff available. We can read so many more news stories. We can have access to so much more information, so many free services. And so, you know, when you get rid of advertising, you throw out the baby with the bathwater. You know, this content out there that's on the internet and that's in apps and so on, it doesn't grow on trees. People make it to make money. And if you make it inefficient for them to make money by making advertising hard, you're not going to have all these great services that you love.
Thank you. I think this is a question for Susan. So at the beginning of your presentation, you described a possibility, a situation when you were talking about Apple might have a preferred credit card, or a certain map application might have their preferred, you know, Starbucks or coffee shop, and they might auction off this preferred status. And I think you presented this as something that we would not like. This might be problematic for innovation, maybe, in these downstream markets. And taking this back to, you know, the question of regulation, towards the end of your presentation you said that when there is this type of market power, there might be scope for regulation. And I just want to kind of go back to what is now the FCC in the United States is kind of trying to enforce net neutrality in the context of ISPs. And I'm wondering whether you think that a similar type of net neutrality would be applied to these types of platforms, like Apple's or Maps. Or should we maybe trust the market to take care of this and not do this thing which might be bad for consumers?
Yeah, well, I think that the market is going to work well in some cases and not in other cases. But so, you know, if you imagine that, like, you know, Apple has its preferred map and Google has its preferred map, and they both auction off preferred status to coffee shops, you know, the consumer might not have a real choice about these things. And so I guess there's like different levels of innovation, and you have to think about which one you're most concerned about. So you go back to like the search example. Of course, the European Commission case was about the idea that, you know, Google took their own products and put them on top, even when that hurt the user experience. And so, you know, you might imagine that one aspect is Google says, well, you know, I was sending traffic to these middlemen, so why would they want to go to Google and then another middleman and then go to where they wanted to go? Why don't we just be the one middleman? And wouldn't that be more efficient? And, you know, if you thought that that Google was the perfect innovator and could always continue to innovate and would always have the best, you know, hotel finder or the best shopping thing, even without any competitive pressure from anyone else, it would be better to just have one middleman. You know, and certainly, like, you know, ultimately an integrated browser and operating system also seemed like a good idea, but it seemed kind of bad for Internet Explorer's incentive to innovate for a while. So if you think that if you think that you don't want to pick winners and you want to have high incentives for third parties to continue to make better shopping engines or better travel search engines or better review sites, you know, then it's really important that when they get better, they get rewarded with more consumers. And so if you have the person directing traffic also have a shop on the street that they can direct traffic to, that's going to reduce the incentives to innovate for the others. And so I do think that that is a legitimate issue, and there are going to be cases where, like, you know, if you've got really, really, really high market share and it's just really almost impossible for a firm to enter in that kind of environment, a new firm to enter, then there's a role for regulation. You know, so that's certainly a concern of mine. And so I think one thing you have to remember is, again, these websites are not static. They are constantly getting better. Every day they're making investments to decide whether they're going to get better. And if they decide that those investments aren't going to pay off in terms of additional consumers, they won't make those investments, and quality can deteriorate very quickly. So there's all these different layers of innovation. You can think of it as like, okay, you know, Google was innovating to make its search engine better, but it's also having consequences for the incentives for others to be better. And if you think someone else might actually be better at something, that not one firm is going to be the best at everything, you might not like all that vertical integration.
So I disagree with one thing you said, but I agree with much of what you said. And the one thing I would disagree with is the characterization of the competition case before the EU. There, the issue wasn't Google's own results at the top of the page. It was putting advertising results at the top of the page. What happened is we've always put text ads at the top of the page, and that was considered to be a normal thing to do. They were labeled as ads. Then we started putting ads with pictures at the top of the page, and that seemed to bother people. Okay? So the issue was not putting Google's own results, quote unquote, at the top. It was putting advertiser results at the top of the page where they'd always been put, but it was just a question of whether they were text or whether they were images. So that's at least how we think of the case. Second point, which I completely agree with, is it's not so much that there'll be defaults. There will always be defaults. That the Edge browser is going to be the default on the Microsoft systems. Chrome will be a browser on the Android systems, and so on. But the question is, how easy is it to change that default, or how easy is it to add to that default? So you could go look at different browsers and say, what happens if I change my default search provider? What's it going to look like to change it on Edge? What's it going to look like to change it on Android? What's it look like to change it on Apple? And you can assess how difficult or how easy it is to change those results. And that is a reasonable issue. I mean, I think you want to add that. It's not whether there's a default or not a default. It's whether that default can be modified easily by the end user.
Add one more thing, actually, on the credit card thing, it's a very interesting point, right? Because you might think the credit cards themselves are a two-sided market with like lots of inefficiencies and super hard to compete with, and they have all of these barriers to entry that tech platforms have as well. So in some sense, if Apple ends up squeezing all the margins out of the credit card companies, well, maybe that's fine for consumers. But if you're a bank or or a credit card company, then you're going to be very concerned that somebody else is controlling your access to your users. And so that's, but whether that's good or bad depends on which side you're on. It's kind of often bilateral oligopoly in some sense, one firm squeezing another.
Okay, so I think I had one more question in the 7th row over there, and I fear that's going to be. Well, let me just go over. I'll take one more round of questions.
Thank you.
So just wait for all of them.
Coming back to what you said on the Google's case, I was wondering, well, what we observe currently, it seems, is that two different attitudes towards data-driven business models are emerging on the two sides of the Atlantic. So we see a relatively critical attitude in Europe with thoughts about obligations regarding interoperability, maybe data portability, also abuse of dominance, and we see a more lenient attitude in the US. And my question really is, what does this mean for the companies? Are these business models operated at a regional level anyhow, so that it's relatively easy to implement different types of remedies? Or will this lead to a trade conflict so that we do need common rules at the international level? I'm just wondering how this works for companies.
So I think Deirdre,
Okay, so let me make a...
Let's
oh, you're going to have another question,
collect
sorry.
one more question, and then you're the first row, and then we'll give you the final words.
So I just wanted to ask you to talk a little bit about data as the actual lock-in issue rather than interoperability or some of the other issues that are struggling around competition, and to ask a specific question that in the US, in the telecommunications deregulation era, one of the things that we did is create both customer proprietary network information privacy rules, but those privacy rules also created requirements for sharing of certain sorts of information because they enabled competition, right? The locals and the long distance and the cellular providers had different access to the sorts of detailed information about patterns of usage of telecommunication services that enabled different sorts of tailoring and profiling. And you know, when we think about market entry and competition here, part of the constraint, for example, in creating a new really great search engine is you're competing with some folks who have very detailed knowledge that serves that long tail, right? And so I'm wondering if you could talk a little bit about the relationship between data protection and competition and personal data as a point of lock-in.
Okay, so we are on coffee time, and I see the organizer getting nervous. So both of you, maybe as short as you can, try and answer those questions.
I'll answer my piece in less than a minute, okay? So the first thing is obligations for interoperability. My view is, because of the chart I showed earlier, where everybody's competing against everybody else, all the people that are competing with the industry leader want to make sure their products are interoperable. And that's what ensures, I think, a remarkable level of interoperability among these different companies. Opinions may differ, that's my view. On data as a currency. I can't tell you how many times I've heard data as a currency in the last 3 days I've been in Europe. Well, I decided to try it out, so last night I had a pizza and a beer. Guy came to me with a bill. I said, let me give you some data. And I'll tell you my deepest personal longings if you accept that as payment for the pizza. No deal. I had to pay in euros.
So I just, in some sense, you know, obviously it would help if you had a situation where there was a violation of the law and you needed a remedy, something like that. Then, you know, providing access to data, it can be really difficult to remedy problems in these types of markets because 5 years later, you know, you can't go back and rewrite history. And so it's really hard for anybody to claw their way back once they're down. So I think that in those types of circumstances, sharing of data could certainly help. But I think it's very hard from a privacy security perspective to think about like kind of systematic sharing of personal data. That like sounds, and it's not entirely clear that it's gonna solve an enormous number of problems. Like, I mean, if it's something really special like search, okay, like everything is the same and you all have a similar search screen, and you know, maybe like sharing data between companies, if there's search engine A and search engine B, and they're already showing results on lots of different websites through syndication, then that data could be used. But it's actually, I think it's relatively rare to have where like just sharing data would help, like because somebody else's website or context is different. And what is really important is access to users. It's the fact that people are affecting consumer choice, and the fact that when you try to enter, you know, you need the users to get the other side of the market, or to get the learnings, or to get the machine learning going, but you can't get the machine learning going without the users. So it's a chicken and egg problem, but just data by itself doesn't necessarily get you over the hump. It's harder than that.
Okay, so I think you'll hopefully join me in thanking the speakers for the great insights and a great afternoon.